enterprise, not virtualization for your home or your desktop. It's virtualization for the enterprise. We all know that, hopefully all of you guys should know that these days, no one really buys physical servers so you can have physical servers. You buy a physical service so you can virtualize a virtual service. Okay, so we all know that. The advantage of that is pretty easy. Okay, if you spend $10,000 on 5 servers and you get this much capacity, and if you only had physical servers, that means you can have 5 different servers, Active Directory, DNS, whatever. But when you're actually using those servers, you might have this much capacity, but in reality, you're using this much capacity. Because you know what? Most of the time, your DNS server, your DHCP server, not going to be that active, are they? So some people might want to combine so many roles together in the old days. That's what they did. They combined AD with DHCP, with web server, with this, but then sometimes they cause interference. Okay, and it goes against recommendation that you put AD with anything else besides AD, really. If you put web server and AD, that's a security compromise because web server allows for access from outside, from the public, really, whereas AD is all about security, so that's crazy if you do that. So therefore, by having separate virtual machines, you're able to isolate each service from each other, first of all. And second of all, if I have this much physical capacity, but only really using this much, I can just add another virtual machine, use that much, use that much, use that much, and then use the capacity more effectively. So so it's just like you buying a V8, but you really only need a 4-cylinder car. Now, what's the point of having a V8, right? And other advantages mean that we're not reliant on the specific hardware. So I could have one server which has Intel, another server AMD, another server with a Xeon processor, another one something else. Because at the end of the day, the network card here might be Realtek, on there it might be Netgear, on there it might be something else. Even the graphics card, we all know there's so many different graphic cards, just different slight versions. And if you had a physical machine, you're constantly getting the right drivers, aren't you? You're downloading the right drivers, and when they update, you have to update the drivers and all that kind of stuff. But we all know with virtual machine, if we create a virtual machine with virtual hardware, we can take that virtual machine to any other computer and we can turn it on, couldn't we? You guys do it all the time. You have your portable hard drive, you create your virtual machines at home, you bring it to tape for me to check it, and you're doing that all the time, aren't you? Was there ever a situation where you couldn't start your virtual machines on another computer? Probably not. The only situation is where you have a paused virtual machine, where there's suspended state, and your CPU at home is a AMD, for example, and our CPU here is Intel. If you pause it at home, you take it here, you can't start it because it's different CPU. You must turn it off and then start it up again. That's because it's like you're trying to change the engine while you're driving the car. You can't just swap different engines, okay? Because your car wouldn't know what to do with it. All right, so they're the reasons why we have virtualization, and then you'll learn later on there's more things. For example, if we have 5 hosts and we have 20 virtual machines, we all know that not all virtual machines are going to be utilized the same amount. Some will be busier sometimes, and others will be less busy, and so forth. So across the 5 physical machines, are they all being utilized the same? So through systems like vMotion and live migration in Hyper-V, we can actually move the virtual machines around on the physical host without any downtime. So the biggest thing in once you get a server up and running is uptime. How do we maintain the service availability and uptime? So by limiting shutdowns due to updates, due to hardware faults, due to overcapacity or stuff like that, you are maintaining uptime and maintaining availability for your users. So that's what it's all about. So today's objective is to understand how vSphere differs from other virtualization products and to understand the difference between ESXi installable and ESXi embedded. And we will have a look at planning and deploying an ESXi deployment. So like I said before, VMware Workstation is a hosted hypervisor. So what does that mean? We have hardware, we have a Windows 10, then we install VMware Workstation, then we create virtual machines. You see that the VMware Workstation sits between the operating system and the VMs. Okay, that means it's hosted because it's got a host operating system. Whereas ESXi, okay, is the VMware bare metal virtualization. What does that mean? Bare metal means that this piece of hardware, that's metal. Means that the hypervisor is installed directly onto the hardware. There's no operating system. No Windows 10, no Microsoft Server, no anything like that. So the ESXi is part operating system, part hypervisor together. Okay, it does the operating system task, does the virtualization task, it's the one product. Why is that better than the VMware workstation? Well, then I don't have to worry about supporting calculator. I don't have to worry about device manager. I don't have to worry about the command prompt for MS-DOS compliant commands, because I don't have to worry about all the extra stuff. I was going to say something worse, but extra stuff that the OS must do. Okay, you think about your operating system. How much of your operating system do you actually really use? There's so much that's a waste of time, isn't it? For you, for the average person, they probably only use maybe 10% of all the stuff that's in their operating system. So all the what happens to the rest of the stuff? It's a waste of time. It's extra resources that's being used. It's extra surface area for attack. Because if I just show you on this computer, I'm sure you guys all seen this before, being diploma students. But if I just look at, oh my goodness, look at all these little things that's running right now. In the background, without even me necessarily starting it, okay? So you can see by username, there's some things I've started, which is fine. Oh, look at that, I didn't even know I had so many instances of Teams running. And there's some things which are local services and so forth, but every one of these things is an opportunity for someone to customize that thing. Every one of these consumes amount of RAM, amount of CPU, amount of resources. Okay, so by eliminating most of the operating system and having bare metal, we are just saving all those resources for what's important, the VMs, the services that we want to provide. All right, so let's get into what we're talking about. So what is VMware vSphere? vSphere is an enhanced suite of tools for cloud computing utilizing VMware ESXi. All right, so it talks about cloud computing. Like I said, what we're going to create in this subject is what's called a private cloud, okay? Private cloud on-premise, okay? So this is more equivalent to what, what's that? AWS, Azure, and other cloud providers use in their data centers. I can tell you now, like Greg used to work for Hostworks. They use massive amounts of vSphere in their data centers. Okay, so VMware vSphere is VMware's flagship server virtualization suite and consists of several technologies that provide live migration, disaster recovery, protection, power management, automatic resource balancing for data centers. Okay, so we'll talk more about each one of these things as we go along, but just a couple of things should be ticking off. Remember how I said it's all important about uptime, isn't it? Keeping the services alive, keeping the services available. Using live migration, migration means movement. Live migration means movement without downtime. Disaster recovery, we all know virtual machines are a bunch of files. Okay, so what happens is that files, if you lose that file, you can have a backup, can't you? We already know about snapshots. We all know you can make a copy, but we have things like we have failover management. So what if we had two pieces of hardware, ESXi 1, ESXi 2. Virtual machines running on this one, but this one, the hard drive just fails. Something happens, it's hard, and it can't run forever. But if that happens, what happens to the VMs on it? Well, the computers can't run. The VMs that's running on them normally just goes off as well, doesn't it? But we just talked about having our VMs running all the time, having uptime, having availability. So what happens to those VMs? Those VMs, if we set up disaster recovery with failover clustering, and in VMware it's called high availability, what happens is that vSphere will detect that that host is dead. And we'll have a record of what VMs were on that host. And because we're going to be using what's called shared storage, we're just going to find another host with capacity, and that's going to take those shared storage files and turn it on this one instead. Okay, so when it dies to when it gets turned on here, it might be 10 minutes. Okay, but it's better than 24 hours if it happens at 3 a.m. in the morning. You have a physical server, and then you go, oh, the hard drive, well, let's say the power supply failed. I need a power supply. Let's go get one from the shop. Get one, replace it, turn it back on. Hopefully it all works. Fingers crossed. Then that's a long time, isn't it? So what we're trying to say, this is going to be very helpful for disaster recovery. So VMware ESXi is the core of the vSphere product suite. Everything else is for management or extra functionality, but ESXi is the worker. Okay, if you want to think about a corporation, we've got some people that's like here at TAFE, we've got some people that help you enroll, some people help clean up the rubbish and stuff like that. There's some people who just has a big vision of where we should be going, and other people which consults with the customers, right? But really, the people who actually does the thing that the customer wants is the lecturer in the classroom facing the customer, isn't it? So if you like to think of it, the ESXi is the one that does the actual work to have the virtualization, the virtual machines, and therefore the services. So it's the hypervisor, which is the virtualization layer. That's what it is. There's two types of hypervisors, like we said, bare metal or hosted. We already talked about that, so we don't need to go talk about it again. But ESXi is a type 1 bare metal hypervisor, and it's an ultra light footprint. Remember how I said Windows 10? How much does Windows 10 take on the hard drive? 10? Yeah, 10 to, about 13, I think. Okay, I know it's 13 because if I go to my...
always 10 though.
Oh, yours is always 10, is it? Yeah. All right, so...
Let's shrink it down though.
Okay, so I know it's about 13. I'm not going to argue with you, but this is a Windows 10 VM, and that's a little bit more. But, and that might have a little few things more in there. But let's just say it's 10 to 15 gigs. Okay. Yeah. So if it's 10 to 15 gigs, who cares how big it is? That's certainly a lot bigger than 70 megs. Okay, because like I said, it's not got all the extra wastage, all the stuff. Again, I can substitute any other word in there, but there's so much stuff that's bloating the Windows 10. Just compare. You guys all know about the server core, not server core, server nano server, don't you, on Windows server? So we know that that's very small, and also server core, which is doesn't have the GUI, it's very small. We also know about Linux, which, if you don't install the GUI, is very small. So the idea of the small, lightweight operating system that has a specialized function is not new. It's across the board. So this one, because its only function is to have basic operating system functions, no real interface really, and to actually provide the virtualization, that's why it's so small. It does not have a service console. You cannot manage the virtual machines directly on the screen with the keyboard. What you have to do is go to another computer, like what we'll do. We'll use our client computer, we'll connect to it through a vSphere client, which is a web-based one, and we manage it that way. Okay, what about vCenter? So we're going to have vCenter later.
Yes, but anyway, we are connecting to a console from another computer. Isn't it called a console?
No, it's not called console. So when you see a console, I'll show you what it is. So the console is...
Is it like to have an agent on a server, so we are connecting to that server?
Yeah, so I'll show you what the console looks like. So when you, so we're at a third computer, right? We're at another computer. This is what you see. Okay, this is when you sit in front of the ESXi with a keyboard and mouse, a monitor, you plug it in, that's what you see. You cannot do anything besides some basic configuration. So basically without a second computer, This is all you see, can't do much. So after that, you then use a second computer, Windows 10 client, you go to a web interface, you log in, and then you use the management interface here. Okay, but this is not on the ESXi server. That is remotely connected to it. Okay, because we all know no one sits in front of the server. Who will sit in front of the server? Unless you love the cold, you love the noisy environment, you love the areas where there's no human being will like, then you probably wouldn't want to be in the server room. So the server room is for servers to do their job, and it's good for them, not good for humans. We sit in our office with our coffee, with our pictures of our cats on our desktop, and then we connect to it remotely. That's why, okay? So let's get back to the PowerPoint. So what about the vCenter? So next lesson, we're going to get the vCenter involved. So today we're going to install the ESXi. Next lesson, we're going to add the vCenter, we're going to connect it all up, and then we're going to add the Active Directory so we can actually put the users from Active Directory as administrators of the vCenter and ESXi, and then we're going to make it all sort of integrated. Okay, that's the plan anyway. So what is the vCenter? The vCenter is a management server. Okay, its job is to manage the ESXis and the infrastructure. So it provides centralized management utility for all ESXi. So when we have ESXi, if we have 10 of them, we must manage each one 10 times. So if we go to ESXi 1, I create a switch, a virtual switch, and it's plugged into this physical network, let's say. Then I go to ESXi 1, create a switch, plug into this one. If I want the same one for ESXi 2, I'll go to this one, create a switch, plug into this one. And if I have 10 of them, I'll go to each one. But if I have vCenter, instead of creating a virtual switch, I can create a distributed switch instead, which is basically a configuration that involves all the ESXi servers I choose. And it's going to take the individual network cards of each of the ESXi server and use it as part of this distributed switch. So I just create it once in vCenter, and all of these ESXi servers that I choose will be part of it. So you do it once. vCenter allows IT administrators to deploy, manage, monitor, automate, and secure virtual infrastructure. To help provide scalability, vCenter server uses a backend database, and this can be numerous different ones, a Microsoft SQL server, Oracle, or something else. And we're going to use what we're going to use instead of actually using, because in our thing it's just a lab. Okay, we don't want anything that's going to make more and more requirements of our resources. Like I said before, we are already going to have it end up with about 5 virtual machines, and then a couple of virtual machines within some of those virtual machines. That's a lot of resources required. So we're just going to try to keep it light. So we're not going to have a full Oracle database server or a full Microsoft SQL server, because that's overkill for our labs. Okay, so we're going to just use the default DB. That's a basic one, and it has only some limitations as well, but it's enough for us to learn the stuff. Okay, vCenter servers include the following features. You can create templates. Oh, what does that mean? Remember how we can just clone virtual machines right now? Remember you guys in my class, we talked about the golden master? That's effectively a template, the golden master. And we create clones, don't we? So in VMware, we actually create a VM virtual machine, VMware workstation, should I say? We create a virtual machine, and then we make clones of that, and then we make it specialized like AD, file server, whatever. That same idea is the template. But you know how in VMware workstation, I told you guys, don't ever start that golden master, right? Because you're going to break it, okay? But in vSphere, they have a proper template. Once you create a virtual machine, you decide this is a template, perfect. Then I make it into a template. Once it becomes a template, you can't start it anymore. Then it's locked in. And then we can create clones from that template to create as many virtual machines as we like. Okay, so as you know, what's the point of the template? It saves you work. Anything you do in the template, you don't have to do again on the new virtual machine. So if that template has an OS, it has VMware tools installed, it has this and it has that, then it's done. You don't need to do it. But just remember, be careful with the template as well. Remember what we did with the golden master? We had to do the sysprep, don't we? So if you don't do a sysprep in this template, it's not a big deal. We did it because we were using VMware Workstation, but with the vSphere, what we can actually do is part of creating the cloning process, we can actually implement the sysprep as part of the cloning process from a template or deploying the template. We can customize VMs. We can rapidly deploy and provision virtual machines, role-based access control, and fine-grained resource allocation. So you'll realize part of our lesson will know how we have permissions to do things, right? We have permissions to read a file, write a file, modify a file. That's fine. That's the file system. We all understand that. We've done that many times. But we also know there's permissions we can set on firewalls. There's permissions we can set on Active Directory itself. Who can create users, who can't create users. But there's also permissions we can set in the virtualization infrastructure. Who can create VMs? Who can change VM? Who can even actually start the VM or shut down the VM? Who can actually open a console to the VM? Who can actually change the networking of the VM? Who can actually mount an ISO into the VM? That's what we're talking about. The level of control is very fine-grained. So we could have users out of our Active Directory. We create groups like web. We'll give you an example. If we have a web developers, okay, they create websites, and we have a web server virtual machines, we might give the web developers the ability to turn on the VMs only. That's it, nothing else. Just to turn on the VMs. Because if they see the VMs, the web server VMs are off, they should be able to turn on, shouldn't they? Because it's got the website. Do I trust them to change the networking? No way, they don't know anything about networking. Do I trust them to add more resources or to change the amount of RAM? No, because they'll be greedy. They just want to give more to their virtual machine. So I can control their access to that level of just turning on, that's it. Okay, so we'll talk about VMware vSphere vMotion. Okay, that's the live migration, VMware's live migration that we spoke about before. There's vSphere distributed resource scheduler. Remember we talked about balancing the resources? This distributed resource schedule, or DRS, will automatically recognize that this host, ESXi server, it's got too much utilization. This one doesn't have enough utilization. Then it will use vMotion to move the virtual machine from here over here, so we can balance it over. Get me? There's no point, if you're working as a team, let's say there's 5 of you, if I want you guys to move the bricks from the trailer to the house, and let's say that Reza's doing 100% work, Roman's doing 100% work, you three just slacking off doing 50% work, that's not fair, is it? So what we can do is just, you do a little bit less, you do a little bit more, balance it up.
So it's actually like a load balancer?
It's like that, but it evens the distribution of the load of the virtual machines across the host by using vMotion to move the host from one host to another host so that the utilization can be balanced. Okay, it's not load balancing where you're sending some traffic here and some traffic there. It's just moving the virtual machine around the host so that the utilization of the resources is balanced. Okay? But not to say that we can't do load balancing as well, but this is just something else, okay? There's vSphere high availability. Remember how I said you can recognize a host is out or a virtual machine is not running, and then we can start it elsewhere. That's what we're talking about, the high availability. There's the fault tolerance as well. This is a little strange one. So if we have, let's say, 2 hosts, ESXi1, ESXi2, we have VM1 running on here. We will have a shadow copy of VM1 running here. So this is the main one. All the users accessing this one. But anything that happens here as well. So there's exchange of information. So if there's a new file added to this server, that file is also added to this server behind the scenes. And the beauty of this one is that if that experiences outage straight away, it will detect it and this will turn on. And this will take over as the main machine. So as far as the user is concerned, there might be a little bit of lag, but this one takes over straight away. That sounds good, but in reality, it's not as easy as you think. Because First of all, there needs to be communication constantly between the hosts. Secondly, the host must be identical in CPU. Okay, because like I said, you can't resume a virtual machine if the CPU are different. Remember why I said that? So if this one has a Intel Xeon CPU and this one has an Intel i7, they're two different. Because the instructions they're sending to the CPU must be suitable for that type of CPU. So if these are the two hosts where we look up the fault tolerance, they must have an identical CPU. Model, everything. Because the instructions must be identical. Okay, that doesn't work. vSphere web client, so that's what I showed you on that picture. This is how we interface with the ESXi and vSphere later on, and that's how we actually administer it. Okay, and this will be more obvious when you actually use it. So there's no point talking too much about it. I showed you the picture, and where is it? Here's an example of that web client. Okay, so this is the way we'll be interfacing with our ESXi. So this VMware vSphere orchestrator, I'm not going to do in our subject at all. We just briefly mentioned it here, because the orchestrator is really the next step after what we learned in here. We're learning the basic how to create infrastructure, but what's the next step? The next step is to automate things. The next step is to actually schedule things, to actually have automated tasks that happens at a regular schedule, because we know that on Monday morning we have a class of for VMware workstation. So we must deploy all of these virtual machines to our hosts, so therefore all the students can connect to it. If that's the case, then we can use VMware Orchestrator to automate that. Okay, so VMware Orchestrator is a workflow automation engine that is installed with every instance of vCenter server. Using vCenter Orchestrator, vSphere admins can build automated workflows for a wide variety of tasks available from the VMware vCenter server. So anything you manually click, you can automate. VMware also makes vCenter Orchestrator plugins to extend the functionality to include manipulating Active Directory or Cisco's Unified Computing System and the VMware vCloud Director. So, like I said, this is just so you know, we're not going to do Orchestrator. So we're going to talk about this in a lot more depth in a few lessons time. But like I said, vSphere vMotion is also known as live migration, allows admins to move running virtual machines from one host to another. So I think you did the Hyper-V subject, right? Yeah, we did live migrations, just called live migration. That's where you take a virtual machine, you move it over there. If you have a continuous ping from another computer, you'll probably miss 1 or 2 ping packets maximum. The migration occurs with no downtime and without loss of network connectivity to the virtual machines, so your clients don't even know. So why would we use it? Let's say this one, this ESXi server, the hardware is going to be retired, it's too old. That's a new one. But all of you guys are my users. They're using the virtual machine that's on here. If I had to do the traditional way of actually just shutting down the virtual machine, turning it on back over there, it might be 10 minutes, but that's 10 minutes where you guys can't access it. So what I'd rather do is I'll just use the live migration, or vMotion in this case, move it over there. You guys don't know anything about it. Once it's all moved, then I'll turn this one off, get rid of it. Okay, VMware vMotion moves the execution of the VM, relocating the CPU and memory footprint between physical servers, where leaving the storage untouched. You probably think, how does it leave the storage untouched but move the virtual machines? If it's running on this ESXi, how do we move it there without moving the storage? Because all of these beautiful features rely on the fact that there's a shared storage. So the virtual machine is actually not stored on any of the physical ESXi servers. It's actually stored on a storage server. That might be a SAN, it might be a NAS, it might be something else. But the fact is, this thing doesn't work, and a lot of the other things like the DRS, distributed resource scheduler, doesn't work unless you have shared storage. So storage vMotion is, you know how vMotion moves the VMware CPU memory footprint? Storage vMotion moves the storage and leaves the virtual machine on the ESXi server. So you guys are looking confused now. All right, we just talked about shared storage. then why are we moving the storage? Well, what if that storage is full? Or what if that's old storage? Okay? So what we're saying is, if this computer is the storage server, this is the ESXi 1, this is the ESXi 2. If I have virtual machine running here, the CPU is here, the memory is here, the network connectivity is here, but the actual virtual machine files are stored on the here, and we're communicating through ESXi, fiber channel, whatever. Okay, that's fine, no problems. And when we have vMotion, we're moving just the CPU memory resources from one to the other. Okay, just basically turning on here, turning off there, really, but switching in between. Storage vMotion is this SAN here. I've got another SAN right here. Okay, so if the virtual machine is running on here, CPU, memory, network, everything right, we leave it. But behind the scenes, we're taking the VMware files and we're moving it here. And then the ESXi is going to be redirected to access the files there, and it's going to switch over. Okay, and as far as, like I said, as far as your users go, I'm using the web server. Look, funny cats, but you don't even know that's happened behind the scenes. Why we want to do that? What if that's getting full? What if that's being retired? Many reasons, okay? So storage vMotion provides ability to leave the CPU and memory footprint untouched. Just leave it there, but change where the virtual machine is stored. vSphere generally means lots of shared storage. Fiber channel, ESXi, SAN, NFS, one of those things is needed, okay? Most of the features, the nice features we would like to have, doesn't work unless you have shared storage. What happens when you need to migrate from an older storage to a newer one? What kind of downtime would it be required? So if you didn't have this storage vMotion, again, just to copy a 120 gig virtual machine, let's say, from one server to another server, takes a long time, right? That means all the users can't access the services. What about the situation where you need to rebalance utilization? So what if that one's getting too full and that storage has only got a little bit? We could move it around, couldn't we? Storage vMotion enables admins to address all of these situations without downtime. There's the resource scheduler, DRS. vMotion is a manual process. Manual process meaning we say move, it moves. But DRS is automatic. So you create rules. You say that if the host is 80% utilized, let's say, then we should move some virtual machines off that one and onto other ones which is less than 80%. Okay, so that's the whole thing. If I have two hosts, I have one which is 90%, one is like 30% utilized, you know, you can see yourself, right? It's not fair, is it? And obviously if the VMs are running on this one, they're going to have going to be slower because of the limitations of the utilization. Whereas this one, no, they're just running. Wouldn't it be better if 90%, 30%, if they were both about 60%? That's more better, isn't it? So that's the whole point of this. Once you create the rules, the DRS just monitors it, see, does it break any rules? Does it go over the threshold? If it does, then it starts taking action. All right, so vSphere DRS performs vMotion automatically, so it uses the vMotion feature that we talked about to automatically move virtual machines between hosts when they're not balanced. So DRS uses vMotion to automatically distribute resources across multiple ESXi cluster members. ESXi clusters operating systems in an active mode, which aggregates the resources into a shared pool. So aggregate means combines it together. Okay, so you, instead of having this much pool for this ESXi, that much resource on there, we combine it together, so we just see a big pool of resources, and DRS just moves things around to make sure it's all being utilized correctly. An ESXi cluster is an implicit aggregation of the CPU power, memory, and all of the hosts. So aggregation means combine, if you don't know what that means. After a host has been assigned to a cluster, they work together to provide CPU and memory to all the VMs. The goal of the DRS is twofold. at startup. So there's two parts to it. When you start a new virtual machine, you press start. DRS is going to look at all the hosts and say, ooh, which one is the best one to start it on? Obviously, the one with the least utilization, right? So I'll pick that one. That's one part. The second part is while the virtual machines are running, and they're going out of balance, they move it around to balance it up. vSphere high availability. vSphere high availability automatically restarts a virtual machine if something fails. Okay, there's numerous reasons. Like I said, if a virtual machine is running on this host, the host could fail. A component of the host could fail. VMs would die normally, but with the high availability, they just restart the virtual machine here. Maybe a 10-minute outage, but it's automatically recovered within that time. But high availability is not just for host failures as well, but what if the VM itself is crashed, blue screen? We've all seen that before, haven't we? Blue screen of death on Windows Server, maybe? So normally, what do you do if you have a blue screen of death on your server? What do you do? Huh?
Switch it off.
Switch it off and then what?
Turn it back on again.
Yeah, we all heard that. We've all heard that before, haven't we? Have you turned it off and turned it back on before? Yeah, probably do that all the time, right? So that's what. So the DRS, the high availability, if it detects a host, not the host, but the VM is not responsive or down, it just restarts again, and that will fix up those kind of things. What if there's a web server on this virtual machine that's running on this ESXi server, but the ESXi server is fine, the VM is fine, no blue screen of death, but the service is no good. The service is crashed. You've seen that before, haven't you, where a particular program is not responding. What do you do there? Restart the whole server or restart do what? Just the service. Just the service, right? You probably go to Task Manager, end the process and relaunch it, right? Because you do it manually. If it's a server, you know that you can go to a service console, take that one service and turn it off and turn it back on, can't you? So we can do that as well, high availability. When we do it, you'll see it. But basically, high availability does not use vMotion. High availability is a failover situation, so there will be a downtime as opposed to vMotion. So there's no anticipation of failure. It is not planned outage, therefore there's no time to perform the vMotion operation. The high availability is intended to address unplanned failures of the physical ESXi. That's the number one thing. By default, vSphere does not provide failover for guest operating system, although you can configure vSphere HA to monitor the VMs to restart the virtual machines. Remember, that's what I said. What if you got blue screen of death? You can monitor them and restart them. And also, this feature is called VM failure monitoring and uses a combination of internal heartbeats and I/O activity to detect if the guest OS is stopped working. If the guest OS is stopped working, the VM can be restarted automatically. Okay. vSphere HA, it is important to understand that there will be interruptions to service. So unfortunately, it has to detect the failure before it can do something. It will be downtime, but hopefully just a short downtime, as opposed to if it happens at 3 a.m. If it's no HA, then you get woken up, hopefully by something. You have to go there and fix it all up. Then there's the fault tolerance. If vSphere protects an unplanned physical failure by providing a way to automatically restart, which is downtime, this needs to restart the virtual machine. The vSphere fault tolerance, or FT, goes even further by eliminating downtime in the event of physical host failure, because the fault tolerance maintains a mirror copy of the virtual machine. Remember, I said there's a main VM over there, and there's sort of shadow VM or copy VM here. Whatever happens there, happens here too. So if that fails, this one just takes over. All right. So that's basically what those extra lines are telling you about. Planning VMware vSphere deployment. Deploying VMware vSphere is more than just virtualizing servers. The deployment affects the storage, the networking, security, equally significant ways of physical, as the physical servers themselves. The planning process of vSphere deployment involves answering some of these questions. What form of ESXi would you use? Installable or embedded? So what does that mean? Installable is where we get a new physical server, we get the installation ISO or USB stick, we stick it in there, we install it based on the hardware here. No problems. We're doing that manually, aren't we? Going to each one and we're installing it. If we have 10 ESXi servers, we install 10. Doesn't take long, but we're doing it ourselves. But what embedded is that you get an image. You get an image. You create an image of what's supposed to be installed. And if you buy 10 servers, hopefully they're all identical servers, because you'd be smart if you get identical servers. If you're not smart, you might not get identical servers, especially if you buy them all at once. Then you create this image, and instead of installing it, I just image on that one, like through the network, image over there, image over there, image over there, and bang, we've got 10 servers up and running. The beauty of the embedded is that, hey, what if one of the servers fails or there's a problem? Just re-image it. Okay, so the next question you have to answer is, what type of servers will I use for the underlying physical hardware? So that's very important, okay? So are you going to get traditional servers? Are you going to get blade servers? Okay, are you going to get hardware which is going to have an internal clustering inside the servers? So let's have actually look at where's my browser? Here it is. Let's go here. So blade servers, just in case you have never heard of this term. So if we go to images, all right, so if we take this as an image, or this man as an image, so what you have with a blade server is you have this chassis, which contains the power supply and all the other networking connections and stuff like that. What he's taking out is one server. So you have, each one of these is a different server. So you're just installing all these servers. They don't have to all be filled, but you can. Okay. And so therefore, instead of, so you can see that's rack mounted. You can see that's 1, 2, 3, 4, probably 4 rack RUs or rack units. And you've got literally, in this case, 1, 2, 3, 4, 5, 6, 7, 8. So you double that, 16 physical servers. Each server has CPU, memory, no storage. Remember, the storage is that shared storage, isn't it? Yeah. So therefore, all of these could be virtualization hosts. That's what blade server's really intention is, because we need lots of CPU, lots of memory, lots of networking, but really we don't need much storage. So that's a blade server. So you're going to have one of those. Is your organization big enough to have one of those, and are you going to expand and add more and more? So you see these ones are blanks. That means there's no server in those, but we can add more if we want to. So it makes it scalable too, doesn't it? And if this is one chassis, you can get another chassis. You can get another chassis. You can keep on adding to it, increasing your resource pool. Just normal servers. Let's just go normal server. This is a typical normal server, and this is taking up one rack RU. Okay, so these are hard drives. This is one server. You can see that's a lot. Actually, this is 2U. So this is taking 2 rack units. Yeah. So this is one server. You can see that's $3,000 something, but that's one of these ESXi servers. Whereas the blade server just then is 16. You know what I mean? So depends on what your situation requires. Okay. So that's a question you have to answer. What type of server would I use for the underlying hardware? What kind of storage would I use? Remember, we need shared storage for all those nice features. How would I connect to the storage? Am I going to get a SAN? with fiber channel or iSCSI. We need something, but we need to decide which one. How will the networking be configured? You'll realize that because all your virtual machines need to communicate with the physical network where the clients are, they have to be able to share that network, isn't it? If you only have one network card on your whole server, that means if I've got 10 virtual machines, they all have to go through that one network card, don't they? So that's a bottleneck. What if I have 3 different networks? A student network, server network, and an admin network, like the workers network, the lecturers. Okay, we want to keep them separate. What if we have some VMs which are only for lecturers, some VMs which are only for students, some VMs for both? How are we going to configure the networking? Ooh, is one network card enough for each network? All right, so probably not. That's because single point of failure, first of all. No load balancing either. And how much traffic is it going to go from the client to the computer? So that's all this decision you have to make. But I can tell you now, you should have redundancy in mind, and you should have load balancing in mind. Because just having one network, 1 gigabit network connection for your servers is not sufficient for all the functions. But don't forget, we'll learn this more, but to manage ESXi, you have to have a management network. So in my scenario, just then where the student, lecturer, server, you could make one of those the management network as well. But remember we had the vMotion? Remember we had the high availability? Remember we had the DRS? All that means there's an exchange of information behind the scenes for those purposes, isn't there? When we do the vMotion, you think there's no traffic between the servers? There's heaps of traffic. So are you going to use the normal network? If you use the normal network, that's going to impact on that performance, aren't you? So there's more than just the networks you need to be physically connected to. There's the networks for the functional DRS, fault tolerance, vMotion, all those kind of things. And like I said, keep redundancy, load balancing in mind. All right, so we spoke about these things briefly. So installable is traditional form of installing, whereas embedded refers to OEM installation of the Hyper-V with persistent storage, and we could actually create images of that as well. Choosing the right server platform, we talk about how important the hardware is. So we need to make sure it's hardware compatible. It's just easier, okay? Because you know how small the ESXi is, right? It's not going to contain drivers for every model of CPU, network card and every model of whatever. So if you buy a piece of hardware where it doesn't have the compatibility, then you won't be able to install straight away. You have to get the drivers. To save yourself a little bit of problem, make sure you get the compatible hardware straight away. Determine the storage architecture. We'll talk more about storage later, but like we'll talk about it's fiber channel, iSCSI, NFS, SMB. But really, there's so many options. Which one do I choose? Things you have to ask yourself is what type of storage best integrates to your existing system. I have existing servers with all Linux. Then probably SMB is not the one I'm going to choose then, okay? Because that's a Windows sharing, isn't it? So maybe NFS, but NFS is not great. So maybe iSCSI, fiber channel, Ethernet are the preferred options, okay? Do you have experience with some of this type of storage? Whoa, maybe I got so much experience with iSCSI. It's pretty obvious then I choose iSCSI. I have no experience with fiber channel. Then probably don't choose fiber channel unless there's a real good reason to do it. Can the storage solution provide the necessary performance? Okay, fiber channel is really fast. And it's lossless, meaning that it's not susceptible to interference, whereas the fiber channel over Ethernet, iSCSI, all are susceptible to EM interference. So is that my situation? Do I have a lot of EM fields around my servers or the connections? Integrating with the network infrastructure, so the decision is driven by choice of server hardware, e.g. an organization's selecting a blade form factor may run into limitations with number of network interfaces. Similarly, a organization choosing ESXi means that if you choose ESXi or NFS, you must use the normal network card for this purpose. If you use the fiber channel, or Ethernet, they have special adapters, so you get those. Okay, so instead of fiber channel, they're in their ESX host to accommodate the additional network traffic, or you can use, instead of the gigabit network cards, because they're just normal desktop stuff, you can get 10 gigabit network cards. You can get cards which have multiple interfaces just to plug into your server. So you can add that to it. Organizations also need to account for the interfaces for these type of traffic that I mentioned before. Those type of traffic still needs traffic exchange. All right, so if we're looking at the guidelines, we need to, like I said, have all these things in mind. What's required for the different physical networks we have, what's required for the management network, what's required for the DRS, fault tolerance, high availability. We need to think about load balancing, fault tolerance. So it's probably needing 2 network cards for each purpose. Okay, 2 network cards for each purpose, so you can have fault tolerance and load balancing. Fault tolerance is if one of them fails, it still can work. And choosing 10 gigabit Ethernet adapters will increase the performance. Remember, all these VMs are sharing the same network card for traffic, aren't they? So the more capacity, the better. So this adds up to, just for those purposes, that adds up to about 8 network interface cards per server. Don't forget, when we're talking about ESXi, vSphere, we're not talking about the small basic companies now, okay? Because obviously the small basic companies, you wouldn't even need vCenter. You just have a couple of ESXi servers, do your thing, done. But once you introduce vCenter and all these extra features, you're looking at larger enterprises. Deploying the ESXi, I spoke about this already. We can interactively install ESXi manually, or we can actually do unattended scripted installation, or we can use the stateless provisioning. Stateless provisioning is where you deploy using vSphere auto deploy, aren't actually installing the ESXi. Instead, they're building the image somewhere. It says somewhere there. Building instead of installing ESXi, you are building environment where the ESXi image is loaded into their memory. So what does that mean? It's not actually on their hard drive. It's just loaded in memory. So when they turn on, they download this image. It's all in memory. So remember, it's only a very small operating system, isn't it? Very small everything. So it's only in the RAM. So vSphere Auto Deploy can use a set of rules to control which hosts are assigned the particular ESXi images. And because the ESXi is actually not installed to the local disk, the new images is as simple if you want to modify it, you can just simply modify the image and just tell them to reboot, and they'll get the new image. So if you've got 100 servers, instead of going off to each one and updating it, we just change the image, tell them all to reboot, obviously moving the VMs off and stuff like that, they'll get the new image profile. So with the embedded, you purchase a system with ESXi already on there, and then you just get a DHCP IP address. You find out the IP address through the console, and then you connect to it, then manage it, modify it to how you need. Some post-installation configuration. We can install the vSphere client. Really, that's we don't have to install the vSphere client anymore. We can just go to the web interface directly. So we said before, the ESXi does not have a console. Instead, we have to use a client computer to access the management through the web interface, which is what we call the vSphere client. But in the past, there's actually a program you install onto your computer, like just a small program. But these days, we just go to the web client directly. Like I said, there's a management network, and you can only connect to the ESXi or the vCenter server across the management network. And this is a security feature. Let's just have a quick look at, we're running behind in time, so let's, Oh, we're nearly finished. We've got a couple more. So if we talk about this, reconfiguring the management network. So we designate a specific network as the management network. And if it's on this one, for example, and this is the production VLAN, we can only manage the network, manage the ESXi servers through this management network. And we also need to synchronize the time. The time is very important, because if all of your computers are not synced at the right time, then it causes a problem with the trust, the cryptography, the certificates. So we should specify a network time protocol provider.